Dear students, today I want to revise the topic work power energy. It's the first part. It includes the revision of concepts work, power, energy, etc. You know the fundamental concepts of work. In physics, you know F dot D, the force into displacement, is said to be work and is treated as a scalar quantity. We can solve the problems with the two different situations. First, the work done by a constant force. It can be found out is equal to force into component of displacement along the force, or displacement into component of force along the displacement. That type of work may be of three types. The positive work, the force or its component is parallel to displacement. There, the action of force with respect to the displacement of this type. And if we split that force into two components, that force got a component along the displacement. The negative work, the force or its component is opposite to the displacement. If you split F into two components, the one component takes the position opposite to the displacement. Zero work means the force is perpendicular to the displacement. The next, a good question. A boy pulls a 5 kilogram block 20 meters along a horizontal surface at a constant speed with a force directed 45 degrees above the horizontal. If the coefficient of kinetic friction is 0.2, how much work does the boy do on the block? Look the figure. Look the free body diagram of the body. Here the force is acting at an angle of 45 degrees. We split into two components. The weight mg vertically downward, the reaction by the surface upward, the friction in the opposite of the force applied. So here the block moves with the uniform velocity. So the vertically we can say n plus f sine 45 is equal to weight mg. And horizontally we can say f cos 45 is equal to mu n. So you can solve it as f is equal to mu mg by cos 45 plus mu sin 45 equal to 11.55 Newton. And this block is pulled through a horizontal distance of 20 meters. So the work done become equal to the done by the force is equal to f cos 45 into 20. You get the answer 163.22 joule. We can move to the next concept, the work done by a variable force. Look the expressions. Integral a to b of f dot ds. In terms of rectangular components, if it is given that f equal to fxi plus fyj plus fzk and ds is given as dxi plus dyj plus dzk, then easily we can find w in terms of rectangular components. If there is a force displacement graph, then area of the graph with respect to x-axis, we can find it by integrating or just to take the area. We are with one question, a good question. A force Varying with the distance is given as F is equal to A into e raised to minus bx, acts on a particle of mass m moving in a straight line. Find the work done on the particle in its displacement from origin to a distance d. So, from this question, how we can use the integration method to find the work? So here, the f is given, it depends upon x. So simple formula, integral f dx. Here, the limit from 0 to d. So you just integrate e raised to minus bx. Apply the limits. So you get the answer. Another question based on the variable force. Is a good question. A body of 4 kilogram mass placed on a smooth horizontal surface experiences a force varying with the displacement of block as shown in figure. Find the speed of the body when the force ceases to act on it. Look the figure. We know the concept of the work done is nothing but equal to the area of the force displacement. So you take the area, you take this small area, that rectangle, and again that triangle. You get the answer. So the gain in kinetic energy, take the value half m into v square equal to 130. You get the answer. Z, a good concept, a chain of length L and mass m is held on a frictionless table with 1/10th of its length hanging over its edge. Find the work done in pulling the hanging portion on the table. Look the procedure. We have to do a good aspect. Say the linear density of the chain is m by L. Say y is the length of the chain hanging over the edge. Then the mass of the chain of length y is hanging is ym. Then the force acting on it due to gravity, mgy. Then work done to pull the dy length, it can be simply write as dw is equal to f into displacement. The minus sign means it's opposite, so equal to. Then you have to integrate between the limits L by n to 0. So we get the answer. So it's a very good shortcut also, a sure type of question. The next concept we have to deal is power. While considering the previous year question papers, we have to give importance to two terms, the average power and instantaneous power. The work done by the time taken, or we can say the change in kinetic energy by the total change in time. The instantaneous means dw by dt is f dot v. For variable mass concept, you can use the concept as equal to v square dm by dt. If you just go through the three different graphs, for the power time graph, you can use the integration to find the work done. If work time graph is there, you can easily find the instantaneous by just taking the slope, the average value again. We can move to the next concept, the very important four concepts. If the coefficient of friction for the rails is mu, then the power of the engine is simple, mu mgv. If the engine pulls on a smooth track on an inclined plane of inclination theta, then the power is the responsible force into velocity as mg sine theta into v. But if the engine pulls upward on a rough inclined plane having coefficient of friction mu, Then P become mu cos theta plus sin theta into mg into V. If it is a down the inclined plane, mu cos theta minus sin theta into mgv. We are waiting with a very good question. A body of mass m is thrown at an angle theta to the horizontal with an initial velocity u. Find the mean power developed by gravity over the whole time of motion of the body and the instantaneous power of gravity as a function of time. Read the question carefully. Here the mean power, we can say it is a net gain in kinetic energy by time interval. Final kinetic energy minus initial energy by time interval. You know, if it is projected with a velocity u, the initial and the final speeds are equal, even though there is a change in velocity. Therefore, the final kinetic energy minus initial kinetic energy become 0. Look the figure here. It is very important to find the instantaneous power. So after some time t, we can find the velocity. We can use the formula. So neatly, that is the x component, that is the y component. The x component as u cos theta, the y component as u sin theta minus gt. The force acting on it is vertically downward as minus mg into j cap. Then what is the instantaneous power? F dot v. So you get the answer as power is equal to mg into gt minus u sin theta. A good concept. The next question. An electric motor that can develop 1 horsepower, the commercial unit of horsepower, is used to lift a mass of 25 kilogram through a distance of 10 meter. What is the minimum time in which it can do this? You know the work done, mgh, 2500 joule, that is power into time. The power is 1 horsepower, that means 746 watt. So time is 2500 by 746. We are waiting with another concept for power. A pump is required to lift 1000 kilogram of water per minute from a well 12 meter deep and eject it with a speed of 20 meter per second. How much work done per minute in lifting the water and what must be the power output of the pump? You know the work done is mgh, the mass is 1000, but it is per minute into 12 into 10. So the work done per second can be found out as 2000 joules per second. Then the kinetic energy gained by the water per second is half m square. So what is the total work done by the pump? 2000 plus 3333. So we get the answer 5333. We can move to the next very important concept. Different previous year question papers together here. A body of mass m, the starting from rest from the origin moves with along the x-axis with a constant power. Calculate the relation between velocity and time, distance and time, and velocity and distance. So look here, we know the power is equal to F into V. F can't be right as m into A. A is nothing but dV by dt into V. So you can cross it. So that is P by m into dt equal to integral V dV. So we integrate it. So we get the formula V is equal to root 2p by m into t raised to half. So V is proportional to t raised to half. From that relation, if you just write Vs dx by dt equal to root 2p by m into t raised to half. So you can integrate again. So here integral dx is equal to root 2p by x into integral t raised to half dt. So after integration, you get x is proportional to t raised to 3 by 2. But we needed to find what is the link between velocity and distance. So you can use these two together. You get the concept as x proportional to v cube. You know the kinetic energy, a positive scalar quantity, and is obtained because of motion. You must carefully notice the concept that the kinetic energy is equal to p square by 2m. So you look the three graphs, the kinetic energy variation with the velocity or momentum, energy with mass, if p is constant, with energy, that's with mass is constant, then E with p. See, for a rotating body, if it is with an angular velocity omega, the kinetic energy takes the formula half I omega square. For a rolling body, it is half mv square plus half I omega square. For a body under SHM, after displacement y, the kinetic energy is half omega square into a square minus y square. If y becomes 0, we get the maximum, the stopping distance, the v square division by 2a. It can be write as initial kinetic energy by retarding force, but with the friction as v square by 2 into, in place of acceleration, you can substitute mu g. We are waiting with a very good question. The kinetic energy of a particle is increased by 300%. Find the percentage increase in its momentum. Please try to avoid a misconcept. Here we can't use the error concept. Then the answer becomes wrong. So use this very important concept. The final momentum minus initial momentum by initial momentum into 100%. But you know how you can link between the momentum and the kinetic energy. So it is increased by 300%. So we can write like this. So you get the answer 100%. See, another good question. A bullet weighing 10 gram is fired with a velocity 800 meter per second. Its velocity decreases to 100 meter per second. After passing through a 1 meter thick mud wall, find the average resistance offered by the mud wall. You know the work done is a change in kinetic energy. It's a very important theorem. The Work-Energy Theorem. It is very important. So we can write F dot is take the value half mv square minus half mu square. So you direct substitution. You get the value, the force there. So the resistance becomes the positive value 3150 Newton. A particle of mass m moves with a velocity v equal to a root x. Find the total work done by all the forces during a displacement from x is equal to 0 to x is equal to d. Here also we can use the Work-Energy Theorem. The work is the change in kinetic energy. So you can individually find what is the initial velocity and final velocity. By putting the value for x is equal to 0, you get v1 equal to 0. By putting x is equal to d, you get a root d. So you just substitute on this theorem, you get the answer. We are waiting with a very good question. A box of mass m equal to 10 kilogram is projected up an inclined plane from its foot with a speed of 20 meter per second as shown in the figure. The coefficient of friction mu between the box and the plane is 0.5. Find the distance traveled by the box on the plane before it stops for the first time. So here it is marked as the first position, the second position. Initial velocity 20, it going to stop, so V2 becomes 0 by traveling a distance x. So look, the component of the weight. At first we can find what is the kinetic energy at the position 1. What is the kinetic energy at the position 2? So we can find what is the total work done. So here the two forces are acting. One the gravity and another one friction. So we had to do extra work against them. So the minus sign is there. So you can just find. It travels to a distance x. So minus 100x. So that is minus change in kinetic energy. So 0 minus 2000. You get the answer. A good concept. You know the potential energy. And is due to the position and configuration. But this is a relevant, very important concept for a conservative field. The force is the negative gradient of potential energy. In vector concept, you can write minus del u by dx del x I minus del u by del y j minus del u by del z k. A very important concept. And see the case. If you just draw the potential energy curve with respect to separation, for the repulsive forces the potential energy is positive, and for attractive forces it make it negative. Look that for spring system it is minus half k square, the gravitational potential energy. The electrical potential energy between the charges. Look the very important two concepts. If a particle moves opposite to the conservative field, work done by the field will be negative. And so the change in potential will be positive. Therefore the potential energy increases. But if a particle moves in the direction of conservative field, work done will be positive. And so the change in potential energy will be negative. Therefore U decreases. So the very important points keep in mind. You know the mechanical energy, the sum of potential and kinetic. For a conservative field we can say it is a constant. The very important point is waiting. The types of different equilibriums, stable, unstable and neutral. If you just tilt a displacement to this cone, if it regains its original position, then we can say it is stable. With never possible, unstable. But if we just give a tiltation, it continue that state, the neutral. So look the important concept. The potential energy should be minimum. And this is the condition. This is the condition for SHM also. Whatever may be the condition, if it is said to be equilibrium, the force must be zero. But in order to differentiate, it may be stable or unstable or neutral. This concept is very important. The second differential of potential. If it is positive, we can say stable. Negative, unstable. Zero, neutral. This is the very important concept. If you look through the different previous year question papers, that you can analyze among work power energy concepts, the very important one is this potential energy concept. Look the very important good concept. The potential energy of a conservative system is given by U equal to ax square minus bx, where a and b are positive constants. Find the equilibrium position and discuss whether the equilibrium is stable, unstable or neutral. You know, in the case of a conservative field, we can say the force is the negative gradient of potential energy. So you can just find what is F by differentiating. So minus d by dx of ax square minus bx, we get the value. But for equilibrium, F should be equal to 0. So that position is b by 2a. But again, we can differentiate one term, you get the value, a positive value. So we can say that position is with a stable equilibrium. A very good concept is again waiting. The potential energy of a particle of mass 1 kilogram free to move along the x-axis is given by, if total mechanical energy of the particle is 2 joule, then find its maximum speed. So here the potential energy is given. For minimum, it's first differential should equal to 0. And also, if you differentiate again, we get a positive value and hence we can say it is stable. But at x is equal to 1, the u become minimum and you get the value minus half g. The total mechanical energy become, the maximum kinetic energy plus correspondingly the potential energy should be minimum. So by substituting, we get the value for the maximum kinetic energy as equal to the total mechanical energy minus the potential energy. So you get the value for maximum velocity as √5. You are waiting a very good question. Two identical cylindrical vessels with their bases at the same level, each contains a liquid of density D. The height of liquid in one vessel is h1 and that in the other vessel is h2. The area of either basis is capital A. Then find the work done by gravity in equalizing the levels when the two vessels are connected. Look here. In the first condition, there is a level difference. By potential energy adjustment, it regains the same level. So how much work is done? It is the change in potential energy. At first, we can find what is the potential energy for these two limbs. So by taking the simple concept, it is mg into h by 2 by using the center of mass concept. Mg is nothing but V density g into h by 2. So you get the formula like that. Then what is the initial potential energy for both the liquids? You get it. What is the final case? But the two limbs are equal in height and hence so we can write as 2 times of this value. Then what is the change in potential energy? You arrive at that concept. Here, a very important question for JEE Main and for IIT aspirants. The last question, a good aspect. A massless platform is kept on a light elastic spring. When a sand particle of 0.21 kilogram mass is dropped on the pan from a height of 0.24 meter, the particle strikes the pan and the spring compresses by 0.01 meter. From what height should the particle be dropped so as to generate a compression of 0.04 meter? So we can use this concept simply. The potential energy half k square is equal to mg h plus that extension. Here the next case we can say h dash plus x dash. Just division, substitution, you get the answer 3.96 meter. So while considering this chapter, the more relevant concept is the different equilibriums and also work-energy theorem. So have to do maximum MCQs, then you can get maximum rank. God bless you. Thank you.